Hi everybody, welcome to section 11.3 and the associated homework number 39. So please, as you watch this video, have the following in front of you. The notes for 11.3, your computer with the video for 11.3, homework number 39, and the theorem sheet and vocabulary sheet for chapter 11, because we'll be referring to those. Okay, here's the calendar for the second week since we've returned from break. And as you can see, here is 11.3 and here is homework 39. And the last day to take the quiz for 11.3 and 11.4 is on Friday. And that is also when the homework for 11.3 and 4 and the review are due. Okay. So, as we know, Chapter 11 is about measuring the length and area of different shapes. Okay, so in 11.3, we're going to learn how to measure area and perimeter of polygons that are similar. So you need to remember that in order for two polygons to be similar, and you might want to jot this down on your vocabulary sheet if it's not already there, okay, because it's important that you understand what it means for two polygons to be similar. So the first requirement is that all corresponding angles must be congruent. So angles are congruent. And then we learned that all corresponding sides must be proportional. So remember, if you have two polygons and we're looking at whether or not they're similar, let me see if I can think of it. So this side is 3, this side is 6. Okay, that's a ratio of 3 to 6 is 1/2. Okay, and this side could be 5 and 10. So its ratio is 5 and 10. 5 to 10, which is also equal to 1/2, and this could be 7 and 14, which obviously the ratio for that is also 14, or 1/2. So that all those sides must be proportional in addition to their angles being equal, their corresponding angles being equal. Remember, not each angle has to be, not all angles are equal to each other, but only corresponding angles are equal to each other. Okay. So here are two similar quadrilaterals. Remember, quadrilaterals have 4 sides. So how do we know that they're similar? So remember that rule that we just talked about. So remember, all the angles have to be similar. And we're told here's a single line angle, here's a single line angle. So those two corresponding angles are congruent. Okay, and here's a double bar, and here's a double bar. So we know that those two angles are congruent. Here's triple bar. So we know those two angles are congruent. And then we have quadruple bar. And we know those two angles are congruent. So all corresponding angles are congruent. I'm going to use a shorthand for congruent. So now the other requirement is that the sides are proportional. So let's look at the corresponding sides. I'm going to change colors here. So these two shapes are turned in the same direction, so it's pretty easy to find which sides correspond to each other. And so usually we go from smallest to largest. So let's take these two first. So that would be 2 meters. The ratio of those sides would be 2 meters to 4 meters. Okay, then we'll take these two sides. Remember, their ratios are supposed to be equal, 3 meters or 6 meters. And here's 2 meters to 1 meter. Uh-oh, did I do this wrong? Yeah, right. I did 1 meter to 2 meters. Sorry. Needed to go the other way. And here's 5 meters to 10 meters. Okay. So the question is, are these equal? And pretty obviously they are, because 2/4 is equal to 1/2, 3/6 is equal to 1/2, 1/2 is equal to 1/2, and 5/10 is equal to 1/2. So, of course, all corresponding sides are proportional. So, yes, indeed, yes, they are similar, and we've just shown that they're similar. Okay, so that gives you a little refresher on what it means for two polygons to be similar. So what about the perimeter of two similar polygons? We've talked about that their corresponding angles are congruent and their corresponding sides are proportional. So on these two shapes, these are the same shapes from the last page, and we know that the angle of their, we know that the ratio of their sides is 1 to 2, is 1/2. Okay? So let's look at their perimeters. Remember, the perimeter is the fence around the polygon. So we have 5 plus 2 plus 3 plus 1, okay, is equal to 11. So the perimeter of this shape is equal to 11. Okay, this shape, we have 10 and 4 and 6 and 2. I'm going to add all those up together to get 10, 12. It's 22. So the perimeter of this shape is 22. So let's check. So the ratio of the two perimeters, smallest to largest, is 11 to 22. Now that should equal 1/2. Okay, because remember the ratio of the perimeters is the same as the ratio of the sides. Let me just check something here. Okay, yeah, we're good. Sorry, I had to check something. Okay, so here we had 11. Where'd she going? Okay, so the ratio of the sides was 1/2, and we calculated the ratio of the perimeters was equal to 11 over 22, and we needed to make sure that they were equal to each other, and sure enough they are, because 11 is half of 22. So not only are their side lengths proportional, but their perimeters are also. So we ought to write that down. So if the side lengths are proportional, then so are the perimeters. And as you can see in a little bit, we'll be using that information to solve some problems. Now, the new news for the day is about the area of two similar polygons. Okay, so now we're talking about area. So that's not the fence around the shape, that's the interior of the shape, the area of the interior of the shape. And again, we're talking about two similar polygons, not just two any kind of polygons. Okay, they have to be similar. So what this theorem tells us that if two polygons are similar, with lengths of corresponding sides in the ratio of A to B, then the ratio of their areas is A squared to B squared. So here they give the little example in the box where the side length of polygon is A, polygon 1 is A, and that's proportional to the side length of polygon 2, which is B. And so the area of polygon 1 to the area of polygon 2 is going to be equal to A squared over B squared. So here's our two polygons again, same ones as the last two pages. And we know the ratio of the sides equal 1/2. We also know the ratio of their perimeters is equal to 1/2. So the ratio of the areas is going to be equal to 1 squared over 2 squared, which is going to equal 1/4. Okay? So remember, the ratio of the sides and the ratio of the perimeters are the same. The ratio of the areas is the numerator and denominator of the ratio of the sides, both squared. Okay, so let's see how that works in action here. Okay. So remember, this only works with similar polygons. So here we have two polygons, and we're told that they are similar. Okay, so all these rules hold. If we don't know that the polygons are similar, then none of this stuff works. Okay, so that's important to remember. So we're asked to find the indicated ratio. So we're looking at the ratio of red to blue of the perimeters. So the important thing to know is that you only need to know, if you know the two polygons are similar, you only need to know one pair of sides to figure out what the ratio is, because you already know they're all equal because they're similar. So if you're given one side, or two sides, one on each polygon, then you know what the ratio is. So the ratio, in this case, the ratio of sides is going to be 8/12, which is 2/3, yeah, okay, and which is also going to be the ratio of the perimeters, okay, so you know the answer to A is 2/3. So for B, the ratio of areas is equal to the square of the ratio of the perimeters. So that's going to be 2 squared over 3 squared is equal to 4/9. And there's your answer for B. Here's your answer for A. Okay, so that's pretty easy. But again, it all hinges on those two polygons being similar. Okay, if they're not, then the whole thing falls apart and you can't make any of these, you can't use any of these rules. Okay, let's take a look at this guy. So, this is a problem very similar to one you're going to have on the homework. So, you're told corresponding lengths in similar figures are given. Okay, given. So you know these are similar figures, so all those rules are going to hold. Find the ratios, red to blue, of the perimeters and areas, and then find the unknown area. So we're going to go small to large as usual, and remember you only need one side to figure out the ratio of the sides and the ratio of the perimeters because they are similar. So here we have two sides. So our ratio of sides and our ratio of perims, okay, is going to be equal to 7/9. Okay. Our ratio of areas, ratio. Areas is equal to square of the ratio of the sides, so 7 squared over 9 squared. Don't forget to square both numbers. Okay, it's the square of the whole ratio, not just one of the numbers. So that would be 49/81. Okay, so now you're given that the area of the larger polygon is 210 inches squared. So remember, we're going smaller to larger. So this has got to be equal to, it's a ratio of perimeters, 210. So the question becomes, what is that area? The area of that smaller polygon. So here we're setting two ratios equal. And you all should remember that the way we solve for the question mark is we use cross multiplication. And it turns out that you should have 49 times 210 equals 81 times the question mark. And long story short, the question mark is equal to approximately 127. So you're not going to get clean numbers in these problems. They've gotten away from that since you're into preparing for Algebra 2 at this point. You need to be able to work with decimals. So these aren't going to come out nice, clean, whole numbers. So you can use this approximation of 127. I think it comes out to 127.005 or something like that. But you can approximate at 127, and that's fine. Okay, so that's how we use that idea of the ratios being similar, or ratios being equal in order to solve a problem. So let's look at one more problem, I think. Yeah. So finding length ratios. So here we're given the ratios of the areas of two, again, similar figures. So we're given that they're similar, otherwise it doesn't work. Okay, is given. Write the ratio of the lengths of the corresponding sides. So by theorem 11.7, as we've talked about, the ratio of areas is the square of the ratio. I keep wanting to write ratio of sides or perimeters, either one. Okay, so the reverse of that is also true. So ratio of sides is the square root of the ratio of areas. Because remember, square and square root are inverse relationships, so you're going backwards. So here we're given the ratio of areas is 16 over 121, and by this rule here, the ratio of sides is the square root of the ratio of the areas. So the ratio of sides is going to be the square root of 16 over the square root of 121. Square root of 16 is 4. Square root of 121 is 11. Okay, so brush up on your square roots. And remember your square roots at least up to 12, and things will go a lot faster for you. So again, when you're given the ratio of sides, you can square it to get the ratio of areas. When you're given the ratio of areas, you take the square root to get the ratios of the sides. So remember that. Okay, hopefully you have written this down in your notes. Okay, finding sidelikes. And this is the last one. Okay, use the given area to find x, y. And again, we're given that these two polygons are similar. That's a little sign for similar right there. Okay, so all the rules are going to apply. So we have this side here and this side here, and the figures are oriented in the same way, so those are the corresponding sides. And this guy is missing, and so that's what we want to find. So, and then, yeah, because that's line XY. So PQ over XY, so that's the ratio of these two sides, PQ and XY, okay, it's going to be equal to 10 over the question mark, and that's what we're looking for. But we're given the two areas, so how do we get from the areas to the sides? So let's set up the ratio from smallest over largest. So the area of the smaller one is 88 inches squared over the larger one is 198 inches squared. Okay, so in order to get so this is the ratio of areas. So in order to get the ratio of sides, we're going to take the square root of that. So we take the square root of 88 over the square root of 198. So again, these are not nice, neat numbers. Okay, they're kind of ugly. So best thing to do is just stick them in the calculator, take the square root, and you get something that's approximately 9.38 for the square root of 88. And for the square root of 198, you get the square root of 198 is 14, approximately 14.07. Okay, and that's going to be equal to the ratio of the sides, which is 10 over our good old question mark. So again, we cross multiply. 10 times 1407 is equal to the question mark times 9.38. We divide through, and it turns out that the question mark is equal to 15, approximately. I should say approximately. Okay, so this is equal to XY is equal to 15. Okay. Now somebody just asked a question, where did you get the 30? And I'm trying to figure out what problem. It's not this problem. No, okay, it must have been a different one. Okay, so that's the end of the slideshow for 11.3. So you can proceed to hopefully you've taken good notes. If not, go back and take good notes because you are going to need these. And then do your homework, and it will be due at the end of this week.